Hello, this is John from caveofprogramming.com. In this tutorial, we're going to add up the number of pixels in each range. So here we've specified a bunch of ranges, and actually now that I've thought about it a bit, I'm going to make this a bit easier by already adding a start range here, which will be 0, and we're going to set it to black. So now for each pair of these, we've got a range of numbers of iterations. So because we've set the maximum iterations in Mandelbrot, in the Mandelbrot class to 1,000, this first range is going to be from 0 to 300 iterations. The second range is going to be from 300 to 500. And I've made a mistake here, that should be a decimal point, because then we want 500 to 1,000. So for each range, we want to figure out how many pixels are in that range. How many pixels have between 0 and 300 iterations calculated by the fractal algorithm, for example. So we're going to need somewhere to store that, and I'll give you an exercise you can try if you want very shortly. But let's go to fractalcreator.h and let's add in here a vector of int, which I'll call m_range totals. Now I want to initialize this with 0 values for each of the ranges, but remember the number of ranges is 1 less than the number of calls to add range here in main, because the first range is from this first one to this second one. So when I add zeros to that vector that I just created, this range totals, I really don't want to add a 0 just for this call. But for each subsequent call I could add a 0, and then we'll have the right number of ranges. So I'm going to do something here which feels a little bit hacky possibly, because I'm worried about comparing 0 in a double to 0, because doubles don't store numbers exactly. But maybe actually I was thinking about checking in the code that I'm about to write if a number is less than a really small number, just so that we can eliminate this one when we initialize our range totals vector. You'll see how this works in a minute. But actually, now that I think of it, I really don't want to do that. Let's go to fractalcreator.h and let's create a Boolean value. So let's say bool m_b got first, let's say got range start, or maybe I could call it something like let's call it got first range, and let's initialize it either in the constructor or right here to false, because that I think is going to avoid having to do anything that feels a bit hacky, and you'll see how this works in a second. So let's save everything, go to fractalcreator.cpp, and now when we call the add range function here, we can say if b got first range. So if we've already got one of these, then we want to say m_range totals dot push back 0, and that's going to initialize this vector with 0 for each of our ranges. And after that, we say m_b got first range is equal to true. So this stuff we got first range is just purely a way of making sure that we don't add a 0 range total for this very first call to add range, because we don't want to do that. And we should see that being called 3 times, I think, here. Yeah, so we've got 4 calls to add range, so there are going to be 3 different ranges between each of these range iteration values. So we could check that. We could just like iterate through the vector. If we say in C++11 I can do for let's say for int value in m_range totals. Actually, this is going to look a bit confusing if I do it here. Let's say range total and endler, and we'll output there the actual range total that we've got at the minute. I'm going to hold off running that because I want to actually run it somewhere else. Let's create a new method now. Let's create one called void calculate range totals. So I'm going to implement this method. We'll go to fractalcreator.cpp and we can maybe put this somewhere near where we're calculating the overall total at the moment. This is in a way kind of misnamed because it's actually calculating total number of pixels within a range, but we're going to remove this later anyway, so I won't worry about it too much for the moment. So now in here, let's take this bit of debug code that I've just written and paste it down here in the stuff that I just wrote. So right in here, we'll paste that. And now let's call that method somewhere. So this calculate range totals, I'll call it from my run method, which is here. Let's put it after this calculate total iterations method, which later on we can delete. So now if I run my program, we should get some debug output from that. Yeah, we need to include also IOStream here. Include IOStream just temporarily because I'm just using it to help me debug the program using namespace standard, which often I prefer to do. We could use the Eclipse debugger, but often I find this way is just quicker. Let's build that, and we've got rid of our errors, so we'll run it. And now we hope to see, yeah, we've got 3 ranges with a total in 0. Now, your challenge here, if you choose to accept it, is to implement this method. Implement this method. You can leave the debug code in so you can see what's happening, so that you fill in the number of pixels that have each range of iterations. So we're going to add that to this range totals vector. So you want to total up the number of pixels that have between 0 and 300 iterations, as we specified here, the number of pixels that have between 300 and 500, and the number of pixels that have between 500 and 1,000 iterations, 1,000 being our maximum number of iterations in Mandelbrot.h. So see if you can implement that. And I'm going to already show you how to do it here, I think, because we might as well just get on with this. So pause the video now if you want to have a go at that yourself. So we'll create a range index, which I'll set equal to 0. This is going to be our index into range totals here. And then we'll have a loop that loops over the number of possible iterations. So we're going to say I less than Mandelbrot max iterations, I++. I'm finally beginning to get used to this keyboard, I think. And then we'll get the number of pixels that have that number of iterations. So we'll say int pixels equals m_histogram brackets I. So that will get us for each number of iterations the number of pixels that have that number of iterations. And then we could say here m_range totals, and range index goes in here, range index plus equals pixels. That would total up all the pixels, and it would just put it in the first range totals element in that vector there. So if we run this, we should see something. I think we see, yeah, it's 438,000, so it's less than the number of pixels on the screen, because many of them reach the maximum number of iterations, which we're not counting. Now, to actually make this work, we just have to put in a if statement. So we want to say that if I is greater than or equal to, we want to check m_ranges, and we want to check the end of this range. So remember, we're kind of ignoring slightly the first range, which just that's just starting at 0. We're interested in the ends of ranges here. So we want to say if it's greater than n ranges range index, I think I've got that right, range index plus 1, then we're going to increment the range index to move on to the next range, like this. Now, if I've got that right, we should see totals in each of the elements of this range totals. So let's run that and see. So there we go, we've got the number of pixels in each range total. Now, one kind of downside of this code is it's really fragile, because someone could easily pass in just wrong values here and really mess things up. We can end up with some nasty errors in our C++ that might even crash the program intermittently. So if you were going to distribute this code, you're welcome to do so, by the way, if you want. Use it in your own project and distribute it. But if you do, you probably want to add some method that checks that these make sense. Make sure that you've got a final range that ends on 1.0, and that you've got a start range as well, and that the other values make sense, they're not negative or anything. So you probably want to add a method that does some checking there before you distributed this code, because otherwise it's going to, you can really screw this up by specifying these incorrectly. Okay, so we'll leave it there for this tutorial. Until next time, happy coding.